Perfect. So, to remind you, we have a lab test one this week. So please make sure you are available. This lab test was 25% and for 90 minutes, 1 hour and 30 minutes. You will have 15 multiple choice or short answers. And also you have 5 programming questions. Right now, my decision is you will receive 10 multiple choice, 5 short answers, and 5 programming questions. Now, if you are on Wednesday, so please make sure you are attending your sections, and it's from 2:30 to 4. If you are on Thursday, we have only 2 sections in Williams Small Center 106 and 108. You can access the recording of all the lectures on YouTube, and also you have the course model where the lecture notes are there, and also the solution for the practice, and there is a common practice online test for all the students in this course from different sections. Last time we discussed compute area apps, and we see how we can grab the user interface items and deal with the user interface items, change the status and the state of the apps. Also, we have random color, and we discuss the object in Java. Today, we're gonna see the method, precondition, postconditions. What is the method? And we gonna see this, how we can define a behavior after we create our object. The method represents the behavior of that object. And also we're gonna discuss the API, how we can read the API, how we can understand by looking to the API, we can know what the method is working, and we cannot know the actual implementation of the method by looking to the API, but we can know what kind of input that this method received, what kind of output this method will obtain, and if there is any preconditions or postconditions applied to this method we have to take care of. And then I'm going to summarize what we did so far in terms of Java fundamentals. Data type conversions, defining objects, and also we're going to cover that JUnit test. Before I start, I will remind you with the most important thing based on your answers is a primitive data type and string object. So a primitive data type is not an object. String is a data type that is actually an object. So a primitive data type is byte, short, int, long, float, double, booleans, and count. Now, these are a primitive data type. Once you ask the compiler to define one variable with these data types, the compiler will go and reserve a certain amount of memory on the RAM. This is not an object, not a class. Okay? String. A string is a sequence of characters. Doesn't mean it contains cars, data types. No, but is actually a class, and it's an object. It's not a primitive data type. It's immutable. Once you create a string, you cannot change it. Now, the Java compiler, Java expert notify that the people are using string very frequent. So they make an options where you can create and destroy the string very fast as you're doing it with the primitive data type. So it's give you an impression that a string is easily to be created and deleted as a primitive data type, but actually it's not a primitive data type. It's a class and it's an object. Now, Java.lang has also what we call a wrapping classes. Later on in this course, we're going to use a collections, and then inside these collections, we cannot store a primitive data type. We have to store an object type. That's why people are using Java, they got frustrated. Why we cannot use a primitive data type with the collections? So the Java experts, they decide to make a wrapping class for each primitive data type. Now, byte with P as small, byte with P as capital, capital is an object data type. So byte with P as capital is a class, it's an object. And also short with S as capital is an object. As you can see, car, C-H-A-R, is a primitive data type, but they decide to use a very long word with C as capital to indicate this is a wrapping class. So for all the primitive data type, even void is considered as a primitive data type, and we have a wrapping class for that. This allows us to use these primitive data type for collections. But after they decide to do this, we need to know how we're gonna create objects, how the object is created and how the object is died. We say that Java has the mechanism of garbage collector, will take care of any unreferenced object in your program and destroy it, and if you need it, we do it, retrieve it back. So a variable that hold either a primitive data type or a reference to an object. Now, if I define a string title as based on the previous slide, we mentioned that a string is a class, and the class is, you can create an object from a class, and we can use the class name as a data type. So a string title. By doing this with a semicolon at the end of the line, no object is created, right? The only thing that we let the compiler know, title is a reference to an object that is not being created yet. How are we going to create the object? We can create the object by separate procedures by using a new keyword. A new keyword by doing this, title, the second line, title equal new string. String is the name of the class, new string. And we use one of the constructor, a string class over a very large set of constructors. And this, we use only one of them on this statement. We give the initial value of the string. A new string, Java for EECS1022. So we give the initial value. And as we mentioned on the previous lecture, we have to give the initial appropriate literal value. So string should be always between double quotations, not a single quotation. So now this we call a constructor, and we create an object of type string. Now, the creation of the object, we call it instantiations, and the object is called an instance of a particular class. So any object you create inside of Java should have data type, a class data type. There is no object exists in your Java programming without class. Creating an object using a wrapping class. As we mentioned, Java Expert provide us with a wrapping class for each primitive data types. So integers with big word, with I's capitals, this is a wrapping class for int primitive data type. So we say integers age equal new integer, we give 40. So as you can see, we are using a new keyword to create an object of integer. And now we give 40 as a value for that integers. Now, once we do this, the object wrapping class can be used for any situation where a primitive data type cannot be used. As I mentioned later on in this course, we're going to come across a concept of collections. Collection only accept object data types. They cannot accept the primitive data type. And that's why where the Java experts create a wrapping class. Now, once we create a primitive data type, we are storing a reference. Once we create a primitive data type, like int age, we go to the memory and we store the value in that locations. But in the wrapping class, we store a reference. Where is that object is stored? So always with the object variables, they are a reference where the object is stored. It's not the actual value. It's different from. Now, the wrapping class provide also many useful static methods that allow us to convert any value data conversions. For example, you use many of these when you are using double.parse double. This is an example where you have an integer's value stored as a string. And you take this string and you make integer parse int. So it's taking the string value and parse it as an integer value. Now, also it's provide very useful constants. This is a primitive type. The maximum number of integers that you can represent and the minimum number of integers that you can represent inside Java. Last time we mentioned autoboxing and unboxing, which is the way that Java tried to make it more easy for the programmers. After they create the wrapping class, they see that they got stuck with using new keywords. So when you define integer, object. So this is using a wrapping class. And then in the second line, you use int number is equal to 42. Now, if you assign integer to object, actually there's a mistake here in that on the third line, it's supposed to be number, NUM. And you assign NUM to object, this will be taking the primitive data type, put it inside the wrapping class automatic for you. So even if you're not using a new keyword, it will do it for you. It's like become like a string object. Okay, so similarly, as we are dealing with a string as a primitive data type, but it's an object data type, they try to make this automated for us. So we take a primitive data type, we assign it to wrapping class automatic. And also the reverse way. You take a wrapping class and you assign it to primitive data type, this will be an automated for you. So this is a process, we call it autoboxing and unboxings. Any question? All this is just a review and putting things all together. Do you have any question? Let us go to the constructors and remind you about the constructor. The purpose of constructor is to initialize the state of the object in well-defined state based on the Java programmer. You are the programmer, you are the one who is creating the class, you are the one who is creating the constructors. You want anyone create an object from your class to make it an initial state or based on initial state. So you make sure that the constructor is allow you to initialize that state of the object. Remember that the constructor can access non-static fields. So it makes sure that all these non-static fields in appropriate values. Now you have some properties or constraint, you can call it. It's not an optional, it's a mandatory that the constructor name should match the class name. Never retain a value. Never retain a value. Even it's void is not retaining void. So constructor does not retain anything. Constructor can have 0 or more parameters. You can have a default constructor where there's no parameters. Implicit constructors that is generated automatically. This constructor, if you provide a class and you didn't provide a constructor for that class, Java will give you one default constructor free of charge. Now, this is the example of declaring the constructors. The name of the constructor should match the name of the class. In our case here, we have a public class counters, and the constructor is called public counters. It's not public void counters. There's no retain. Public counters. And in this case, we are using no argument constructor. There's no parameters or argument. It's just empty parentheses. And we make sure this constructor initialize the state of counter to a 0. So this dot value is equal to 0. Now this is a reference to the object is being constructing. You are asked to construct an object. This can be used to reference to the object that you are trying to construct right now or try to manipulate right now. A copy constructor, sometimes you create an object, you spend time creating the object, but you don't need to destroy this object by changing the status. You try to copy the same state on the other object. That's why we have a copy constructors. A constructor chain is very powerful style of programming where you make sure that the only one method responsible for creating the object and any other constructor calling this constructor. So you have one main constructors and other constructor calling this constructors. So this is very important. If you decide to use a constructor chain and you're going to use this keyword, this should be the first line. You cannot use this on the second line of code. So once you are using this, you have to make sure this is the first line of the constructor body. This cannot be used in any other methods. Stop doing this. You cannot use this to invoke the constructors. You can use this, but you cannot use this and you ask to construct an object inside a method or instance methods. This is an example where the constructor chain, we have the first constructor, default constructor, gonna call the middle constructor. The middle constructor responsible to receive two arguments, x and y, and assign this x, this y. And this is a copy constructors where the copy constructor, the last constructor, is calling the middle constructor. This is a constructor chains where you can see the middle constructor is always responsible for creating the objects. And always this is the first line of the body, and actually there is only one line in this case. Okay, this reference is to resolve any ambiguity between the instance variables and the parameter for that method. Also, it can be used to pass the objects as a parameter to another method. And questions. All this is just a review for what we already covered. Any question?
Can you give the reason why we need a wrapper object?
Later on in this course, we're going to use what we call a collections, data objects, where we're going to collect some objects together. We cannot use a primitive data type with a collection. That's why we have a wrapper class. Any other questions? Okay. The method. After you create the object, you decide how many variables you need. You need to create the method. Method is from some sort of computations, and also method is reusable. You can reuse it once you are defining the method. Everyone can use it. You don't need to recopy the code of that method. And actually, you don't need to know how this method is implemented if the appropriate API is provided for you as a user for this class, as you saw in I2C, which is the jar files created by the author of the text part. You don't need to know the detailed implementation of any method, for example, to convert between meter and feet with inches. The only thing you need to know how it can send input and how I receive that. And if there is any conditions for the input or the output. You can read more about the method and API. For example, I can go to this link, and this link will take me to the jar file. The jar file is created by the authors. And as you can see, we have a very big list of classes and description for each class. Let's say utility class, where you can see there's no constructor for this class. So this is a class without a constructor, or even the constructor is a private, so we cannot create object from utility class, but we have a set of methods that we can use. One of them is, for example, is a factorial method. We discussed this last time. So the factorials, this is the API. The only thing you need to know, it's receive int as a input and retain a double as an output. This is written on the header. Public, static, double. Double is the retain type. It's public for everyone can use. Static, that means you can access it with the name of the class. You don't need to create an object to start using the factorials. And also, retain type. What's the retain type? It's double. And also the name of the method, factorial. And then between the parentheses, the list of input arguments. In this case, we have only one input argument, and the type of it is int. Okay? What's the method doing? Determine the factorial of the past integers, and also the parameters. N should be non-negative integers. Now, it will throw an exception in case of n is negative. So the author, or I can say the Java programmer who create this method, he take all the necessary precautions to make sure that no one can send a negative value for the factorial. So once he pick the negative value, throw an exception, stop executions. Some people, they're not doing anything, they unexpected behaviors, and will retain n factorials as a double. So by only knowing these few informations about the method, I can use this method. I don't need to know the implementations. I don't need to know the implementation of the method. There is a lot of list of methods. I encourage all of you to look at it and try to use it. Back to the slides. This is the method API. This is a method where it's called is between. And as you can see, this method is public, static, boolean, retain type boolean, either true or false. And also the name is between. It's take int 3 inputs, int minimum, int max, and the value, and check if this value is strictly between the minimum and the maximum. So as you see in the description, return true if the value is strictly greater than the minimum and strictly less than the maximum, and false otherwise. So by looking at the description of this method, I can sense what this method is doing. I don't need to know the implementations. Now, is there any restriction on the parameters? Minimum value, maximum value, there's no positive or negative restrictions, there's no through exception, but there is a preconditions. That's what we call it in the last line. There is a preconditions. Minimum less than or equal to the maximum. So we have to follow this preconditions as a user for this method. If we didn't follow, as you can see, there's no exception will be raised or a flag to tell us you made a mistake. You send a minimum greater than the maximum. You will receive unexpected behavior. So for you, as a user for this method, you have to read the API and make sure you follow the preconditions before you are using this method. Otherwise, you will receive unexpected behavior. Now, some programmers, they take all the necessary precautions, and this is the recommended for you, to take all the necessary precautions to raise a flag or stop execution once the precondition is violated. Okay? Now, one of the things that we have to discuss is the header of the method. As you can see, this is the header of the method. This is a complete header. Start with a quantifier public, static, then retain type boolean, and we have, this is the modifiers, this is the retain type, this is the name of the method, and this is the parameter list. This is a complete header. Okay? The parameter list, it play very important role on the method headers to identify the method signatures. So you cannot make or define or reuse the same name of identifier inside the parameter list. Int min, int max, int value. I cannot say int min, int min, int min. It's contradiction. You're defining a 3 variable with the same name, and that is wrong. So we cannot duplicate the parameter name inside the parameter list. You have to give a unique name on the parameter list. Again, the parameter list play a very important role on the method signatures. We discussed the header, modifiers, retain value, the name, and the list of parameters. What is the method signature? The method signature is actually the name of the method and the data type of the parameters and the order of these data types. It makes it important. So, as you can see, you don't need all the header information to create a method signatures. What is the method signatures? The name of the method and the list of parameters and the data type of this parameter and the order that you make. For example, if I define is between int and int, so this is the signature. If I say is between int double int, this is another signature. Is between double int and this is another signature. So the data type for this parameter is very important, and the order they are appear on the method header. So this is a signature, the name and the number and data type of parameters. If I give you this method and ask you what the signature of these methods. So the first one is string to upper. What is the signature for this method? To upper, car, correct, car at, int index. What the signature? Yes. So you can see I don't care about the return type. The only thing is important, the name of the method and the data type and the order of the parameter list. This is a different signatures of is between. I can say public static boolean is between, and then I will start working with the double numbers now, not integers. So it's a totally different method, and I can add it to the same class. Method overloaded is when you have two or more methods on the same class, but they have with different signatures. For example, these are two methods. We can define them in the same class, but with different list of input parameter and data type. You can see the name of the method is the same, is between. So that is the one of condition for method overloading, but the input parameter is different. Not the name. I don't care about the name of min, max, value. I care about the data type. So the name is the same, but now in Java, and this is one of the things, when you define the method, not a constructor, well, when you define a method, you have to make sure you have a retain data type. Now, someone say, I have a method that do some computation, but I don't need to retain anything. How should I solve my problem? Yes? Void. We can use void as a retain data type. Now, this method is retain boolean. I have to specify. So if you specify a method without a retain data type, Java will not compile. You have to use the retain data type. Now, someone say, I would like to do a method where it's retain a list of values. In this case, we told him, just wait until we cover an array. You can define an array and retain an array as a single value, but is a list of all the values inside the array, or a collections. Method of precondition and postcondition, we mentioned this. So precondition is a responsibility for the client or end user like you, must make sure these preconditions true immediately before the method is called. So as a user for a is between, I have to make sure the minimum is less than the maximum. Otherwise, I will receive unexpected output. Might be the output is true, but I receive false.
Can you return an object?
Hmm?
Can you return an object? Can you return any return statement? Can you return like an object?
Can I create?
Return an object.
Yes, yes, good. You can define object inside your method and retain a reference to that object. You have to make sure that we call by value or call by reference. Okay? So if you are retaining a primitive data type, you retain the value of the primitive data type. But if you are retaining objects or a reference to class, you retain the address where this object is located. Java will not duplicate creating the object, otherwise you will run out. Okay? So you create a string, okay, and you return a reference to the string. But what's good about the string is a mutable, okay. But for example, if you later on we're going to see this when we cover the collections. Collection is a list of all the objects. So when you retain, you cannot create a copy of all these objects and retain them. No, you retain actually a reference where this object is located. Yes, you can define an object inside our method, and we retain a reference to that object. Postconditions It must be ensured when you are programming a method, you have to make sure this is true before you return. Okay, when you write a method, you should make every effort to detect any violation for a preconditions and stop executions, okay? Or a print appropriate message. Okay, remember, a primitive variable contains the value itself, but the object variable contains a reference or address where that variable is stored. Object reference can be thought as a pointers, where is the location of the object stored in the memory. This is an example for num1 is a int data type, and we store the value 38 inside it. But name1 is a string data type. We're not storing the string on name1. Name1 is a reference, contains address where the string is actually created on the memory. See the difference between the primitive data type and the reference data type. Now, it's very good to see the assignment, how it's behaved with the primitive data type and how it's behaved with the reference data type. So here, before we create name1 and name2, each one of them store a reference, where is the string is located. Now, if I say name2 is equal to name1, what you expect? Exactly. So that is what happened. Now the content, ECS course jobs, I don't know where is it. It's there on the memory, but no one is pointing to it. Now, I was used to use the name2 to retrieve this string, ECS course jobs. But now, since I make the assignment name2 is equal to name1, I have no clue how I can retrieve that information. Now, as you can see, two references are pointing to the same objects. And this happened for any object on the Java. You have to be careful when you do this assignment. And this creates a phenomena, what we call it an alias. Alias, two or more reference referring to the same objects. This is an alias. That's you have name1 and name2 referring to the same objects, or maybe more than that. Okay, so that's create an interesting situations inside your Java programming where you can refer to the same object with different name. But this should be carefully used, okay? Because if you modify an object using one reference, the other references also see the same thing. So we have to be careful. Alias is good, but we have to be careful when we are using them. So changing an object through one reference will affect all the other references, okay? Any questions about aliasing? I encourage you to go at home, try to practice and see the assignment with the primitive data type, how they are behaved, and the assignment for reference, how they are behaved. Now, this is the API. We discussed the API. This is the list of the classes, and also this is the class summary and main information about the classes. You can retrieve one, for example, this is a student class. As you can see, this is a student class to create CSE students with an ID and name, and you can see it has methods equals and get course grades, and the method retain data type, the signature of the methods, and some information about the method you can read. This is a repeat, just to pick one for example. I will look at the header of the method and let me know what is the signature of this method. The signature of the method. I need to know the signature of the method. Okay, what about int? You give int data type and you give char as you repeat and then. What is the retained data type? String. So this is javalong.string is just the full name for the string. And this is public. Everybody can access. It's a static. What the meaning of static for you? What when I told you this is public static, what does it give you an indication? That is, no, that's not correct. This is good. This is good. Not correct. Static doesn't mean it's not, it's fixed. Static means when you define a variable static inside your class, you say all the objects from this class will have the same copy, but I can change this copy. Okay? Be careful. Static with the method, what that mean? Yes? That's right. You don't need static with a variable or with the method. You don't need to create an object to use this method or use this variable. Okay? So public, everybody can access. Static, I don't need the object to use this. Retain data type is a string. Repeat the name, and these are the list of parameters. And let me just go. So what is retain? Is retain a string contain the count of repetitions. How I can use this one? I can define a string str1 utility.repeat. I give count 2 and then I give a character a. And as you can see here, it's very important to know that when I have a data type, I give a literal value that is compatible with the data type. I didn't put double quotation a because this is a string data type. But this case, in my method, I have a character. I have to use one quotation. So I use one quotation and then I ask to retain the data type, the appropriate data type, because otherwise there would be a problem, a compilation error. So I cannot say str1 double, because this method retains a string data type. So I should receive it on the string data type. Okay? It's like someone, I don't know how I come. You have to know the retained data type and create the variable suitable with the same data type to be able to receive that retained data type. Okay? That's the only thing you can do. This is the output. I can change and run many times, use the same method. Now, if I told you public class equations, and you can look at this class, this is a static class, how someone can use this method, this class. This is the API of the class. Is not static, then we have to create an object of the equations to be able to use it. So we have constructors. So the author of this class will provide equations, constructor, default constructors, and also we provide with an equation A, B, C. What is A, B, C? I have to go back to read the description. You can see it's a create a second order equation A x squared bx plus c is equal to 0. So I know A, B, C is consistent with what I'm looking for, and also we have a copy constructors. So I can use this by creating equations, the name of this class used as a data type, equal 1, this is the name of the variable, and also new equations 1, 0. What is this equations with these input parameters? 1 for x squared, 0 for x, and 9 minus 9 for c. So this is x squared minus 9. So by reading the description of the API, I can use the class. I can define object inside the class. What is the method inside this class? Equals. I can make sure that two equations are equal to each other. I can get coefficient. I can get the root and give the number of roots. So for example, I create these equations and I ask for the first root and ask for the second root and retain the value. So all of this about reading the API and using the method. Any question? So if I give you the API, you should be able to read it. You should be able to figure out method signatures. You should be able to figure out how to use this method. Or if I give you the API for the class, you should be able to know how to use this class. Any question? Okay. So now I'm gonna just go over what's so far covered. Then we're gonna start the JUnit test topics. It's a new one. Good. So packages. Do you have a question? I will go over the slides. If you have a question, raise your hand. Okay. Packages. What do you know about the packages? You are Java programmers. When someone to package in the Java, what is flags in your mind? Okay. Import statement. What is import statement in Java? Why we need to use import statement? Is there an execution time for import statement? If someone have 10 import statement and the other one is used customize one import statement, this one with 10 import statement will execute slow, or this one with customize will execute fast. There's no execution time for import statement. You can import all the classes, or you can import nothing. You cannot say, I would like to import everything except this class. There's no such kind of things, okay? There's no such kind of things. Packages is to organize your work inside directory and folders. Classes. All these discussions about Java programming is about class. Create your own class. We create many classes on this course. Circles, address, students, okay, rectangles. We define static class. We define non-static class. We create object from class. We use a class as a data types. Okay, and these keywords come with classes. Okay, these are each keywords with some meaningful descriptions about it, but we didn't cover everything because this is an introduction course. Okay, in 2030 we'll cover more and more in advance. A new keyword. When I say a new keyword on Java, what is in trigger in your mind? What is the power of a new? Why we are using a new? To create an object. To create an object of any particular class. What is the method? Once you define the class, you say a set of, you define a circle as a class. You say I have a radius and a center point. Now, I need to calculate the area of the circle. So this is defined as a method, a behavior associated with your objects. And you have to pay attention to the retain statements. Any method should retain something, single value. If you don't need to retain anything, unfortunately, you have to mention void on the header. Constructors. Oh, this is very, very good. This is very powerful way to construct the objects. And you have default and customized constructors. You can have many constructors as you want. There's a special name for a copy constructors. There's a special name as a default constructors. There is a parameter constructors. There is a constructor chain. All this you need to know. But there's a must. If you would like to define a constructor, you have to make sure the name of the constructor is equal to the name of the class, the same name. Okay, how to access a member of the object, if it's static or non-static. If it's non-static, that means I have to create the object, then I access it. We call it instance variable. If it's static, you don't need to create an object. You can access the variable or a method with the name of the class. You don't need to create the objects. This is an example. We have a circle and we define public static final pi is equal to 3.14. Now, as you can see, we have a private double radius. Radius is an instance variable. So whenever you create the object, you have a different value for the radius. But for all the objects from this circle class, they will share the same pi value. So as you can see, all the instance objects are sharing the pi, but they have different copy of radius. Okay, static, that is back to your questions. Static does not mean constant. Okay, you can change it, but this means that all the objects share the same value. Okay, the same thing. You have a static method. You don't need to create an object for this to access the static method. You can use the name of the class. If it's an instance method, that means you have to create an object. A static method, as you can see, we can ask math for a max, math for a square root, which will retain a value. Static method cannot access non-static fields or non-static methods. That is come with the same concept, aligned with the same concept. If there is an instance variable and an instance method, you cannot use them without creating the object. But if you have a static variable and static method, you can use them without an object. So it's fair enough that a static method cannot access non-static variable and cannot access non-static method, because that is contradict with the concept. If you have a static method, you can use it without an object. Okay, so if you have a static method, you cannot access non-static fields inside your static method. You cannot access non-static method. Okay, constructor cannot be static. You cannot define public static and you give a name of constructor. Constructor cannot be static. Okay, a primitive data type, reference data type. So whenever you define int number 1, you define it, you reserve a space in the memory, and you store value in that space. Reference, or they call it a class data type. So it's called where is the address, give you the address, where is the object is stored. This is a string definitions, where str is stored the address where the string is actually there. And you have to remember the aliasing issue, that you have two reference pointing to the same objects. This is a very good thing, but we have to use it carefully. Assignment, we have to make sure that the assignment is written in an appropriate way. When you have a data type, you assign a right value to that data type. Okay, arithmetic expressions, multiplication, divisions, remainders, additions, subtractions, and how they are orders. Rational expressions, greater than, less than, equal, not equals. Always these rational expressions return true or false. Logic expressions and or, these are also combine the variable and constant of arithmetic data types, and the rational expression with the logics operations like and or XOR. You can define whatever you like, but also the retain type is and, true or false. Any question so far?
Wait, so why would we specifically use a static method or static class over another?
Yeah, so sometimes like utility class that's defined by the author of this textbook, it has some set of methods, but I don't need to create an object. Math class is created by the Java expert for us to use to calculate the maximum between two integers, the maximum between two doubles, to calculate the sine, cosine, to calculate exponent, to find the square root. I don't need an object of a math class. I need the method of that class. So that's why we define the methods as a static. We define by. I need a by value. I don't need the object to use by value. That's why we define by as a static value. So whenever you come across in your application or your programming task for a situation where you need some set of methods, but you don't need an object to use this method, then it's best to use a static methods and static variables. Data conversion is another thing that you have to be careful about. We know that Java do the promotion technique where it's moving into long and float and then doubles. So this is integers. 14 divided by 3 is equal to 4. 8 divided by 12 is equal to 0. This is an integer division. Even you can see the numbers. There's no decimal point, so this is integer number. So this is an integer division based on the operand. Now, this is the remainders. We have integer operand, and we are using remainder operations between 14 and remainders or modulus of 3, and that will return true, 2, sorry, and 8 modulus of 12, that will retain 8. So the remainder of the divisions. Okay. Division with double numbers. If the both operand of the divisions are doubles, like what you see here, this is 14.2 divided by 3.1. So the operand is double, the value is double value. 8.6 divided by 12.7. So the operand is double, so this is a double and this is the value. Remainders operation should not be used with double numbers. That was early, but after that, we have on Java 1.5 is allow us to use the modulus operation with the double numbers, and the result is unprotected. Yes?
The answers will be the same even if one of the operands is double.
Yes. So, the modulus operator can be used with doubles, but the result is unprotected. Okay, you have to understand this. If I give you these equations and I told you how they are executed in orders. So the first one, A plus B plus C plus D plus E, all the operation is AND, so we start from left to the right. The second one, can anyone give us the order? Yes? The result? Okay. So the first one, we're going to do multiplication, then we do the divisions, then we're going to do the addition, then we're going to do the subtractions. It's very important to know the order to evaluate any arithmetic expression inside Java. Once you put the parentheses, you force Java to start from that location. As you can see, P plus C will start first. Then we go to the division, then we evaluate the modulus operation or remainders, and then finally we do subtractions. Now, the last one we have nested parentheses. We start from the nearest one or the nested one. So we start with D minus E, then C plus, then we have multiplications, and then the last thing we do the divisions. We have increment operator plus plus and decrement operator minus minus. That's to add one or subtract one, and we can use them pre or past. So we can have a statement like count plus plus, which is equivalent to count equal count plus 1. So this is a very powerful shortcut we can use inside our Java code with increment operators and decrement operators. So the total is defined, and then we have int equal count is equal to 2. And then I say total is equal to count plus plus. What is the behavior in this case? Count will be equal to count plus 1. Then you have the values. Give us the values. Total will be 3 and count will be 3. That is not correct. Is that correct? No. We're going to go to the count and pick the value is equal to 2. And then we assign it to total, and after we increment count to 3. So in this case, total will be 2 and count will be 3 because this is a post increment. So we take the value of count, assign it, then we do the increment. So we have to be careful about the past and pre-increment. This one, you are right. Both will have 3. So this is a pre-increment, we call it. We're going to take the count value is 2. We increment it first. Then we assign it to total. So there is a difference between pre-increment and post-increment. Any question? But always increment operators and decrement operators increment by 1. Increment by 1.
So I know it's covered, count still equals 2, right?
The previous one?
This one.
Oh, it's written on the slide. Count is equal to 3 and total is equal to 3. On the previous slide, count is equal to 3 and total is equal to 2 because it's post increment. So the previous slide, you're going to take the count, assign it to total, then increment it. In this slide, you're going to take the count, increment it by 1, and assign it to total. Also, the Java expert, they make it shortcut for us. For example, if you would like to evaluate x is equal to x plus y, you can make a shortcut, x plus equal y. This is translated on side Java as x plus y. If you have x minus y, x is equal to x minus y, still you can take a shortcut for that, x minus equal y. The same thing even for the mod operations, the last one, you can have x mod y or modulus y, so you take the value and assign it to x, so you can do the shortcut for this. So all this is a shortcut, you can use them inside your Java code to make it more optimized. If I give you this one, what is the equivalent of this one? This is a shortcut arithmetic expression written in Java. What is the equivalent on a mathematics? Yes, result is equal to result divided by whatever on the right hand side. Okay? Java testing. Sometimes you create a method and you would like to test this method. Sometimes you have big component inside your app. It's very hard to wait until the last minute to run the app and then see what is wrong. It will be hard for you to go back and debug where is the source of the problem. So JUnit testing is a technique that's offered by Java. This technique is offered for us to make sure that we can do testings incrementally as we are developing our Java programming. This is not only for apps, not for only Android Studio. You can use it for any Java programming. You're going to use it later on 2030, on data structures, later on in your career as a programmer. Okay? So let us see what is the, you have a system, as you can see, A connected to P, A connected to C, C connected to D, C also has some connections to D, and also you have C is connected to D, but there is no connection between P and C. So you are building a system, and either you're building an app or a big Java application programs, and you have different components and they are interconnected with each other. So unit testing is testing the modules by itself. So by taking A aside, doing testing for it, and make sure the A is working. Integrate testing. I see the connection between A and P. I want to test these connections. I test this connection. Make sure that A and P are working together. Now I add C to my system. And now C is connected to A. I test the connection between A and C, but there's no connection between C and P. There's no need to test connection between P and C because they're not connected to each other. System testing, which is you put everything. Now, after you are unit testing, integrating testing, the system testing, you try to test the system all together and then acceptance testing. You take the system after it's passing the system testing and you try to put it in the real. You give it to your end user. Try to this system and give me whatever your feedback. Okay, you put your system on the real live environment and you see what is the feedback. Actually, unit testing this is what the programmer most of the time, they spend time, 70% of their time, they are doing unit testing. Just take one unit aside and test it. Imagine you have an airplane and you don't need to do unit testing. You say, okay, I want to build this airplane. Like P.Eng, what they're doing. They put all things together and they let's fly and see if it's going to crash or not. That's not acceptable. We have to do unit testing. And this is very important for you as a programmer. You're doing maybe you see they are a programmer in a big company, but this big company is responsible for a bank transaction. And you don't need to do unit testing. Why should it matter? This is good to calculate the interest. Then put your method inside the applications and run the application and let us see the user feedback. Either good or bad, I don't know, but you are inside the real life system. So unit testing is very important and you have to take it seriously. Okay, step to manage, implement a big apps or a big complex systems. So individual parts verified before the integrations. Integrated subsystem should be also verified. If adding a new part break the system, what give you indications? The old parts is a problem with the old part, with the problem with the new part. Exactly. So you go back to the new part and try to fix it. This ultimately leads to the complete system is working. So this is simply the recipe. So if you want to make it sure, write a little bit of code, make sure it's working. Then add another little bit of code, make it sure it's working. Doing this gradually to finish your app. Okay? I hope you do this when you're doing these for the labs. Later on, you're going to see that you have many methods working together, so it's very hard to verify them. So what does the unit testing do? Create the object, for example, call a method, verify, retain type. You have the actual value and you have expected value. You try to verify them together. And this was like a recognition testings where you are automate the process of this testings to see the bugs and notify whenever there is a problem, and so you can go and fix the bug to destabilize the or stabilize it actually. Okay, Android testing framework. You have the Android framework provide a JUnit test inside the Android. Now we are talking about the apps, Android apps. They provide a JUnit testing, which is they call it a local testings. You can do it. And also there is an instrument unit testing. We're not going to cover an instrument unit testing because this is a course not for app programming. This is for Java programming. So we're going to cover the JUnit testing. Now, this is a class I created, and it has only one static method. It's called multi-difference. So it's multiply, and then they take a difference between the addition. So you can see it's only one line. So you take two integers as an input argument, and multiply x times y minus, and put between the brackets x plus y. Now, if I would like to test, because this is the JUnit testing, you have one method, or you create one class, you want to make sure this class is working or not. This is just the class with only one method. I would like to make sure this class is working or not. So I can use the main approach, public static void main, and then I do the pencil and paper, do the calculations for this method. If I have input 1 and 2, then the result should be -1. So I print a message. Then I see, oh, very perfect. So my code is working. Or this is not inefficient. Imagine you have a big system and every time you're going to do this, you are working with a point, guys, and you want to do main. So every time, wait for me to write a main method. Oh, then I have to run another JUnit test for another thing. So no, that's not good main approach. So we have to come up with something. So we use the JUnit. So this is Android Studio. I'm going to go back to the Android Studio. Then I will cover this slide. Then I will take you to the Android Studio to see a demo. But let me just go over this slide quickly. So this is a JUnit. It should be inside the Java folders. As you can see, when you open the Java folder for your apps, you see the apps, then Android testing and test. Android testing for instrument testing, that we're not going to cover. The testing folder, the third one, this is what we're going to focus to write the JUnit test. And then if you open that, expand it, you're going to see there is a one example, they call it example unit test, and there is some example already written for you. But you're not going to use that example. You're going to create your own JUnit testing class. So you right-click, you say new class, and you say multi-different test. You end the name with the test, or whatever you name you like, but it's good to have the test at the end to indicate this is a class responsible for testing these functions or this method. Okay, good. Then Android Studio will give you an empty class, public class, multi-different test class, and it's an empty. You can ask, right-click, generate. I would like to generate test method, and it will give you a public void, name, and empty parentheses and empty body for the method. Now you are able to write your JUnit testing. So we're going to change the name to test. I give a name question 31 underscore 0 multi difference, and I give the input argument input x 1 y equal to 2. The result, I calculate the result. This is a static method. I can call it with the class name, class a dot multi x and y, and I know the expected value is -1. Some of one say, oh, I'm repeating the process of the main. No, yes, you're repeating the process in terms of the pencil, paper, and verify. You know the actual value, you know the expected value. But this will be automated run for you for all the app. Later on, we're going to see you can run test all the method inside my app or test individual methods inside your app. And then you create the string, which is the user method. If this test is failed, the user know what is the failure. If you run the app and there is a failures, you know where is the failures. So you assert equals. Assert equals say, make sure the expected value is equal to the actual value. In case of they are not equal, make this message. Okay, this is import assert. You have to import appropriate packages, input arguments, the actual value, expected value, and then you assert equals. There is a lot of assert statements. I encourage all of you to look at it. They assert true, assert false, okay, sometimes. But assert equals is the most famous one. And this is the message that you're going to print it to the user. You can do many testing. I can do many tests for the same method. In this case, I have 3 JUnit tests. I can run all of them or run individual. If I run them all and everything is working, I can see on the top part of the image, the slides, everything is working. And if there is a failure, they will let me know that the expected value should be -1, but the actual value is -2. So I go to this method and revise it. Now, I can have many methods inside my class, and I have different class to test each one of these methods and can run them all at once. So let me now go back to Android Studio and show you this on actions. So you have the class, as you can see here. This is the main approach. I don't need to use the main approach. Okay. Now, inside my method, I have 1, 2, 3, 4 classes. I can create a JUnit class test for each one of these and test each one of these methods individually. How I can do that? I can go to the test folder and right-click a new class and give a name. In my case, I already created for you. We have, for example, test computations. I put the import messages. I make sure I define the JUnit test. This is how actually I graded your program. So I create the JUnit test and I use this JUnit test to run it for all of these response I receive from students. So I make sure you have a compilation error and if it's working and it's working correct or not. So I have some samples inputs. I ask to compute and then I print a message. I can ask to run this individually for each one of these JUnit tests. Okay? Or I can define a new environment. I can go also to run this one individually. But let's say I define many JUnit test classes. And it's better for me to go individually for each one of them and run. Is there any approach I can run all the JUnit for all the app to make sure all the app is working? So I can go to the environment, say edit environment, and I can ask for a new one. I wanted Android JUnit. It will ask me, give a name. I can say all JUnit. I want that to be all packages in the whole projects. Then apply, OK, and ask to run. Now, Android Studio will go over all these JUnit classes. As you can see, let me just here. See, all these classes, and each one of these classes has some test. So I can run all of them. And also, this will run individually, each one of them, and I can go verify in case. As you can see here, everything is running perfect. There is no error. So I can know that the compute method is working fine. The convert method is working fine. The multi-different method is working fine. And also some squares is working fine. This is how the JUnit test is working. Okay, any question? As you can see, we have a class, and inside this class we have different methods, and for each method we have a separate class JUnit test, and inside this class we define many tests. Now, someone he decided to create one JUnit test and put all these in one class. It's his decision, but we advise and recommend you to have a separate JUnit test for each method. Now, if you would like to run them all, there is an option on the Android Studio. You can create the environment where you can run all these JUnit test classes. Any question? Any question? Okay, so I'll stop recording here.